Hi friends, welcome back. Today we're talking about graphing parabolas in standard form. Now, there are a bunch of different ways of graphing, and I want to show you my method. So pay close attention to all of these examples so that way you've got a good understanding of it. Okay, so the first and foremost, remember, standard form looks like this: ax squared plus bx plus c. So when we have a quadratic that is in this form, we need to figure out how to graph it. And so the most important part when we're graphing a quadratic is to find that vertex, or when we're graphing a parabola, is to find that vertex. So let's take a look first at our parent graph. Our parent graph here is y equals x squared. Here's what it looks like. You start at 0, 0, that's called your vertex. You go over 1, up 1, over 1, up 3. Over 1, up 1, over 1, up 3. We have a axis of symmetry right along in there on 0. It is a, sorry about that, making sure it focuses. So let me draw this in. So our axis of symmetry is right along our axis here. So it's, in this case, x equals 0. But our pattern is what's most important. What is most important here? Now you heard me say over 1, over 1, up 3. So we went up 1, up 3. Up 1, up 3. That's going to be really important for how you graph these. There is another way of graphing it, but I'm lazy. I like to show you the easiest thing possible. So I think this is the easiest way. So we're going to try it this way. All right, let's get right into it and launch right into these examples. Like I said at the beginning, the first thing that is the most important is finding your vertex. And so to find our vertex in standard form like this, the way that we do this, remember, it is A, B, and C. So to find our vertex, what we do is we say x equals negative b over 2a. X equals negative b over 2a. Now, when we do that, we get negative 2 over 2 times 1, because negative 2 is our b and this is our a. So we get x equals, that's positive 2 over 2, so x equals 1. Okay, so we found the x for our vertex. Now, when we are trying to graph these, there's some really important information, and I wrote that right here as part of your notes. Your vertex, your axis of symmetry, and your pattern. So our vertex we now know is 1 comma something. I don't know what the y is of my vertex until I plug it back into this guy. So y equals, and instead of x, I'm going to use the x from the vertex here. So 1 squared minus 2 times 1 plus 4. So that gives us 1 minus 2 plus 4. That's negative 1 plus 4 gives us 3. So y equals 3. So the vertex is 3. Okay, now that we know our vertex, so we go over 1, up 3. Over 1, up 3. There's our vertex right there. Now that we know this guy, what we can do is establish our axis of symmetry. And your axis of symmetry is always written as the equation of a line. So our AOS is x equals, and you use whatever the x is of your vertex. So x equals 1. So what I mean by that is the equation x equals 1. If I was just to graph that line, it would look like this. It would go through 1 and it would go straight up and down like that. That means whatever happens on one side of our graph is going to happen on the other. Now, let's go back and look at my notes. Remember that pattern I told you about? 1, 3. It actually goes up one more. You go over 1, up 1, over 1, up 3, over 1, up 5 if you want to do another one. So 1, 2, 3, 4, 5. So see how it's going all the way up there. So it's 1, 3, 5. Over 1, up 1, over 1, up 3, over 1, up 5. You're always going over 1. So we have our axis of symmetry here. We have our vertex and we have our axis of symmetry. Now what we need is our pattern. And our pattern comes from our A, which is in the very front here. If it's a 1, it's our normal pattern. 1, 3, and 5. Meaning we go over 1, up 1, over 1, up 3. Again, over 1, up 1, over 1, up 3. Now we could go up 5 if we wanted to. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, just like that. So there is our giant parabola. Now, do you have to remember that pattern in order to do it? No, ma'am, or sir, or captain, however you are. We can do this because we have our axis of symmetry. What happens on one side happens on the other. So we can use an XY chart to figure this out. So since my my vertex is on positive 1 here. Let's plug in 2. So I'm going to take this equation right here, and I'm going to use, another piece of paper here. I'm going to say, okay, here's our equation, and we're going to plug in 2 for x. So we have y equals 2 squared minus 2 times 2 plus 4. And when we do that, we get 4 minus 4 plus 4. That gives us 0, so y equals 4. So when I plug in 2, I get 4. Now, I'm going to go over, so that was, we've done 1, we have 2, let's do 3. So if we plug in 3, we say, okay, y equals 3 squared minus 2 times 3 plus 4. 9 minus 6 plus 4. Okay, so we get 3 plus 4, so y equals 7 here. So we go over 3, up 7. Now, if you take a look, that pattern that we used, go over 2, up 4. 1, 2, 3, 4. Go over 3, and then 7. And so over 1, up 1, over 1, up 3 gave us this without us having to do this extra work of plugging in. This works really well when you have an a of 1 or an a of 2, 3, 1/2. It doesn't work great when we have a's that are kind of complicated, and I'll get to that. Let's practice that with another one. All right, so with our standard form, so the notes that you'll definitely need are this. So your standard form, to find the vertex, we first find the x by saying x equals negative b over 2a. Then we take that and we plug that into our function to find our y, and that gives us our vertex. Remember, when we're doing these, the important part is to find your vertex, your axis of symmetry, vertex, axis of symmetry, and we want to know our pattern. Okay, so let's take a look at this guy right here. To find our vertex, we'll do the work down here so you can see. X equals negative b over 2a, and in this case our b is 2. So negative 2 over 2 times our a is negative 1. This gives us negative 2 over negative 2, which equals 1. So for our vertex, our first number is 1. Now to find our x is 1. To find our y, we need to plug that in. Negative 1 squared plus 2 times 1 plus 2. So I get negative 1 squared is 1, so negative 1 plus 2 plus 2. So that's going to be negative 1 plus 4 gives us 3. So our vertex is 1, 3. I swear this isn't the same as the other one. It just looks like it's the same. So our vertex is 1, 3. Our axis of symmetry, we always, again, write that as the equation of a line. X equals whatever our x is, 1. So let's go ahead and graph that. We go over 1, up 3. There we go. And then we have our axis of symmetry is x equals 1. So we draw the equation of the line like this. Now, our pattern, we look at our a here, and our pattern, our a is still a 1. But this time it's negative. The only thing the negative tells us is that we're going to be opening it downwards. It doesn't tell us, it doesn't change the pattern at all. So our pattern is still going to be 1, 3, and 5. But this time it's going to be opening down. So instead of going over 1, up 1, over 1, up 3, we're going to go over 1, down 1, over 1, down 3. So over 1, down 1, over 1, down 3, over 1, down 1, over 1, down 3, just like that. So there is our parabola. Now again, we can see if we didn't remember this pattern, once we have our vertex, we pick 2 x's, and then whatever we get for those, we just copy it onto the other side. So like in this example, we would again use 2 and 3. Because if I go over 2, I should get positive 2. Well, let's try and plug that in. Y equals negative 2 squared plus 2 times 2 plus 2. Okay, so y equals, now there are no parentheses here and we don't want to introduce parentheses. So this is negative 4 because it's saying, hey, do 2 squared and then slap a negative on it. Negative 4 plus 2. Well, negative 4 plus 4 is 0. So y equals 2. So when I plugged in a 2, I got a 2. And hey, look, my pattern did the same thing. Over 2, up 2. Perfect, that's that spot. Now, so when I plug in a 3, I should get negative 1. Let's try it. Y equals negative 3 squared plus 2 times 3 plus 2. So y equals, again, we want to do 3 squared, which is 9, and slap a negative on it. Negative 9 plus 6 plus 2. So that's negative 3 plus 2. So that gives us negative 1. So when we plug in 3, we get negative 1. And sure enough, that's exactly what happened. So from our axis of symmetry, all we would have to do is copy this to the other side on both of those. And then we've graphed that parabola. But I think the pattern is the easiest way for you to think about that. Let's try another one so that you can see what that pattern looks like. Okay, so looking at this guy right here. Again, we look at the front, and if it's positive, it's going to be opening up. If it's negative, it's going to be opening down. And so in this case, it's going to be opening up. We got to find our vertex, our axis of symmetry, and we want to know our pattern. And our pattern in this case, we look at our A, and it's going to be 1, 3, 5 if you want to. I almost never use 5, but that way you know it's there. So to find our vertex, we're going to do x equals negative b over 2a. Our b is negative 4. So just like that first one, negative 4 over 2 times our a, which is 1. That's right in the front here. So that gives us negative gives us 4 over 2, which equals 2. So the first part of our vertex is 2. And then to find our y, we're going to plug that in. So 2 squared minus 4 times 2 plus 7. So we get 4 minus 8 plus 7. So it's negative 4 plus 7. That gives us 3. So when x is 2, y is 3. So we're going to go over 2, up 3. Now, our axis of symmetry is always written as the equation of a line, x equals, and then we say whatever our x is in our vertex. So that's 2. Because again, what happens on one side of this line here is going to happen on the other. So now our pattern is 1, 3, 5. Bam, over 1, up 1, over 1, up 3. And now again, because it's on the opposite side, we can do over 1, up 1, over 1, up 3. And there you go, you've just graphed this. Again, if you don't remember your pattern, you can always plug, in this case, I would plug in 3 and 4 to see what happens and then mimic it on the other side. Okay, let's talk about what happens when that pattern is not 1. So let's look at this guy to start with. We have y equals 2x squared minus 16x plus 28. So the first thing we want to do, again, is find our vertex, our axis of symmetry, and so vertex, and then our axis of symmetry, and our pattern. Now, our pattern in this case, and this time we know it's opening up because it's positive, but our normal pattern is 1, 3, 5. And this time we have an a of 2, so we take our pattern and we multiply it by that, so we get 2, 6, and 10 for our new pattern. 2, 6, and 10. Really, we're just going to use the 2 and 6, but that's fine. So to find our vertex, we say x equals negative b over 2a. That's going to be negative 16 over 2 times 2. So we get 16 over 4, which equals 4. Okay, so the first part of our vertex is 4, and to find the second part, our y, we're going to need to plug that in. So if we take this guy, we'll use it right here so that you can see. We come back up to here, so we say y equals 2 times 4 squared minus 16 times 4 plus 28. All right, be very careful here. You don't want to do 2 times 4 and then square it. No, you got to square first. So we have 2 times 16 minus, now 16 times 4 will give you 64 plus 28. And so this is 32. So 32 minus 64 plus 28. Now don't make this mistake where you add 64 and 28 because you got to remember it's a negative there, right? So if I add the opposite, let me add up my positives. I get 32 and 28 gives me 60. So I have 60 plus negative 64. That gives me negative 4. So when x is 4, y is negative 4. So we're going to go over 4, 1, 2, 3, 4, and down 1, 2, 3, 4. Perfect. Now, if I didn't know my pattern, what I could do is plug in 3 and 2 and see what happens, and then copy it on the other side because again my axis of symmetry is right along in here. But fortunately this is an easy enough one where we can do the pattern. Let's first, our axis of symmetry, remember, is x equals, always the equation of a line. Don't just write 4, you have to write x equals. So x equals 4. Now my pattern is 2, 6, and we're not going to worry about 10 because that's going to be way off the graph. So that means we go over 1 up 2, over 1 up 6. Again, that's over 1 up 2, over 1 up 6. Just like that. And there we go. You'll notice this one's skinnier than the last one. And that's because the larger this number is, the skinnier this is going to be. What happens when this is less than 1, when it's a fraction, like 1/2 or 3/4? Well, in that case, it's going to be fatter. Let's talk about that. That's what happens here. So we have 1/2. So for this guy, again, we want to find our vertex. So to find our vertex, we're going to say x equals negative b over 2a. And that's going to be negative 2 over 2 times a, which is 1/2. And let me back up and say that because this a is positive, it's going to be opening up. So this gives us negative 2, and then half of 2 is 1. So negative 2. So the first part of our vertex is negative 2. Now, to find the second part, we're going to plug that in. Y equals 1/2 times negative 2 squared. Notice I'm using parentheses. You have to use parentheses when you're inserting a negative, especially when you're squaring it. Otherwise, you'll get the wrong answer. So we look at this, and again, we want to do our exponents first. So 1/2 times quantity negative 2 is negative 2 times negative 2, which is positive 4, plus negative 4, because 2 times negative 2, plus 6. Now, half of 4 is 2, so 2 plus negative 4 plus 6. So we have negative 4 plus, and then our positives are 6 and 2, which is 8. So that gives us positive 4, which is good because I was running out of room. All right, so there's our vertex. We know it's going to be over negative 2 and then up 1, 2, 3, and 4. Okay, so looking at this, now we've got to talk about our pattern. So our pattern is normally 1, 3, 5, but in this case, we're going to multiply it by our a, which is 1/2. So we're going to have 1/2, 1 and 1/2, and 2 and 1/2. So that means when we go over, so our axis of symmetry, let's not forget that part, is going to be just like this, and it's the first part of our vertex. So our vertex is here, which means our AOS is going to be x equals negative 2. And that's this line that I've just drawn here. And so we go over 1 up 1/2, over 1 up 1.5, right there. You can also go over 1 up 2.5, like that if you want to do that. Over 1 up 1/2, over 1 up 1.5, and then over 1 up 2.5, like this. And there we have our parabola. You'll notice this is fatter than that parent graph that we started with. That's because the smaller this number is, less than 1, meaning less than 1, the fatter it's going to be. Okay, last one. We're going to do one more. This is a one that's wonky because it's got negative 3/4. This is a weird pattern. So when you have a weird pattern, we want to make sure that we do something like I said at the beginning, where we choose an x and our XY chart. So we're going to first find our vertex, and we're going to do that by x equals negative b over 2a. And our b is 6, so negative 6 over 2 times negative 3 over 4. That negative in the front tells us this is going to be opening down, so we got to remember that. Now, this is negative, I'm going to draw it right over here. So this is negative 6 over, now divide this by 2, I get 1. Divide this by 2, I get 2. So it looks like negative 3 over 2. We got some side work to do here. This is a complex fraction. Now, so a negative divided by a negative is going to be a positive, so I'm going to drop the signs. But this is 6 divided by 3/2. 6 divided by 3/2. Remember, we never divide fractions, we multiply by the reciprocal. So my side work here is 6 times 2 over 3. And if I put this over 1, I can cross cancel, or I can, which is what I did up there back when I had 2 times negative 3/4. Or I can multiply straight across the top and get 12 over 3. Straight across top, straight across the bottom, that's 4. So fractions are side work, do all your side work over there. So all of this garbage equals 4. So the vertex here we've got is 4 so far. Now, in order for us to find the next part of it, we've got to plug it in. Y equals. Now, in this case, I'm okay with you using decimals, but you want to double check with your teacher just to make sure. Remember, 3/4 is just 75 cents, 3 out of 4 quarters. So negative 0.75 times 4 squared plus 6 times 4 minus 9. Okay, so we've got negative 0.75 times 16 plus 24 minus 9. So if we do that, we end up with, this is going to be negative 12 plus 24 plus negative 9. I just added the opposite there. Okay, so 9, 10, 11. So that's negative 21 plus 24. I just added my negatives together. And then I get positive 3. So when y is 4, I get 3. All right, so we go over 4. 1, 2, 3, 4, up 3. Bam, there's our vertex. That's important information. And once we have our vertex, we also have our axis of symmetry, which is x equals 4, because it's just that x there. Now, and that goes right along in here, just like this. Okay, so this is one where the pattern is really wonky, so we're not going to do that. Instead, what we're going to do is, since this is 4, we're going to choose 5 and 6. So we're going to make an XY chart, and we're going to say 5 and 6. So what happens when I plug in 5 here? Y equals negative 0.75 times 5 squared plus 6 times 5 minus 9. All right, remember, we do this part first, so 25, and that gives us negative 18.75 plus 30 minus 9. Okay, so if we, and using your calculator, if you have wonky ones like this, I'm sure your teacher will allow you to use your calculator, because otherwise it's kind of a pain. So we get y equals 2.25. Okay, so when we have 5, that's 2.25. And then for 6, when we plug that in, y equals negative 0.75 times 6 squared plus 6 times 6 minus 9. Okay, so when we do this, we get negative 20. So again, 36 times negative 0.75, we get negative 27 plus 36 minus 9. So when we enter those guys into our calculator, we end up with 0. Y equals 0. So when it's 5, we go over 2 1/4. So we go over, or I'm sorry, when it's 5, we go up 2 1/4. So we go over 1, 2, 3, 4, 5, and we go up 2 1/4. So right there. And then when we go over 6, it's 0. Now, because we know it on this side, we just copy it over to here. And so now we know when we have 1, 2, 3, so 3 and 2.25, and then 2 and 0 because of that axis of symmetry. So hopefully this helps. This is a lot. I appreciate you hanging in there. We'll see you next time.